we are going to start with 5.1, which deals with operations with polynomials. Okay? So first we're going to start with how to simplify expressions. When you simplify an expression, it means you have to rewrite the expression so that you get rid of any parentheses, you combine common terms, and you get rid of negative exponents. In the simplified form of an expression, there should not be any negative exponents. Okay, this stuff we already know, all right? And we're going to rely on the fact that we know this from Algebra 1. So look at this, product of powers. If I have x to the a times x to the b, what do I do to the exponents? Add them. So if I have x to the 5 times x to the 3, that should be x to the 8, right? Do we know why that is? Do we know why? Well, we know why. This is x to the 5, right? Times x to the 3. How many total x's? X to the 8. So you have to add the exponents, right? All right, so quotient. If I have x to the 5 over x to the 3, right? And so now that's 5x's over 3x's, right? How many am I left with? 2, because you subtract, right? So you're going to subtract. So x to the power of 2. All right, negative exponent. When you have a negative exponent, in order to make it into a positive exponent, you have to move it either from the top to the bottom or from the bottom to the top. So if you have, just like this one. So if you have 2 to the negative 3, that's 1 over 2 to the positive 3. Now, if you have 1 over 5 to the negative 2, same way, you move it up. So it'll be 5 to the power of 2. Okay? You can either move up or down, and that's how you get rid of the negative exponent, the negative part of the exponent. Yeah.
Oh, so if it's on the bottom, you move it up.
If it's on the top, you move it down.
Oh.
Okay. Powers of powers. So if you have x to the power of a to the power of b, look at this one. D to the power of 2 to the power of 4, right? You multiply the exponents. Well, why? Let's take another example here. Here. You multiply them. Why? Because you have x to the power of 3 squared. So if you have x to the power of 3, is that it? Yeah? Now, squared, it means you multiply it by itself. So multiplying that by itself will give you x to the power of 6. Okay? Power of a product. So if you have x times y in parentheses to the power of an exponent, that exponent belongs to everybody in here. Okay? Same with the quotient. Okay, and what's anything to the power of 0? 1. Okay. Let's think about what a monomial is. A monomial is a number, a variable, or an expression that is the product of one or more variables with non-negative exponents. Okay? No powers of powers, right? So no x to the power of 3 to the power of 2. Each variable should appear once. All fractions have to be simplified and no negative exponents. Okay? All right. So here, right, that's how it looks. All right. So we're going to combine these terms. Okay. So you have a to the power of negative 3 and positive 2. And they're being multiplied. So it's going to be a to the power of negative 3 plus 2, right? We're going to add the exponents. B to the power of 4, that's alone. C to the power of minus 1, can I write it that way? You have to move it down. So let me just leave it now. Because Here I have a to the power of minus 1, b to the 4, c to the minus 1. Okay. Now, b to the 4, that's good, stays. A to the minus 1, both a and c move down. Okay? A to the 1, c to the 1. Yes. Yeah. All right, here. What are we going to do? You're subtracting these exponents. So it's n to the what? Negative 8. But what's going to happen with that negative 8? Is it going to... It's 1 over n to the 8. Yeah. Or you could just say, okay, I'm dividing, right? Things are going to cancel. I have 2 n's on top, 10 on the bottom. I'm going to cancel 2, but there is an extra 8n that are going to stay on the bottom, right? So basically the way I look at it is, okay, definitely going to subtract the exponents. 10 minus 2 is 8. Where are there more n's, top or bottom? Bottom. So the n to the 8 will live on the bottom. Okay? All right. Who does this exponent of 2 here belong to? Everything. Right? Yeah. So it's 3 squared, which is 9. A squared is a to the what? 4 over b to the 4. Can I simplify that further? No. Ooh, b to the 8, b to the 8. Okay? You multiply them.
Oh.
Okay, the degree of a polynomial. No, you could only simplify coefficients, not exponents. Okay, so the degree of a polynomial is the exponent, so not degree, but it's the exponent, that's a better word, of the monomial with the greatest degree. Okay? The degree of a monomial is the sum of the exponents or degrees of each variable. So first, state whether each expression is a polynomial. Okay, in order for it to be a polynomial, okay, all exponents of variables have to be positive integers. Okay? So a polynomial means exponents of variables should be positive integers. So take a look at that first one. Is that a polynomial? What's the exponent of the x? Here, of the first x, you have x to the 1. What about the y? It's 1, but it's underneath, right? So technically, that's like xy to the minus 1, right? Right? That means that can't be a polynomial. So if you have a variable underneath, can't be a polynomial. Okay? Not a polynomial. So basically, you can't have, you can't have variables in the denominator. What about b? Is that a polynomial? Polynomial, yeah. Okay, now we need to think about the degree. Okay? Look at this one here. What is the sum of the exponents in that term? 6. What is the sum of exponents in this term? 7. How about here? 2. Because the highest degree is 7, we say the degree equals 7.
Oh,
You add them, yeah. Uh-huh. We don't mind. Okay, so let's simplify this. So basically this negative gets distributed, right? So I have negative x squared minus 3x plus 4 minus x squared negative 2x plus 5. Okay? All right, and now we're going to combine like terms. So negative x squared, negative x squared, negative 2x squared, negative 3x, negative 2x, negative 5x, 4 plus 5, positive 9. Right? I know you've been doing this since like pre-algebra. All right, when you have a plus in the middle, there is no need to rewrite it, right? We're just going to add terms. So it's going to be 3x squared minus x, and then here we have minus 6 plus 1, minus 5. Okay? All right, distributive property. This is how it looks, right? Yeah. Okay. Oh, and here. Oh. See, that's a little parenthesis over there, so it worked. Anyhow. Okay, so we're going to distribute this. Each one is going to get a 4 over 3x squared. So, first off, 4 over 3 times 6. X squared times x squared will be x to the 4. Plus 4 over 3 times 9. X to the cubed, x to the 3. Minus 12 times 4 over 3. Okay, so here it's 8x to the 4 plus 12x cubed minus how much? 16 x squared. Okay? Yes. Yeah. I would rather you did. Yeah. Okay, here. Distribute. Okay, negative 2 times negative 3. That's going to be positive 6. Now, a minus 1 plus 2 is just going to be a 1, right? So a to the 1. Okay, minus minus plus 22. A to the what? A to the 0, which eventually will be a 1, right? Correct. So minus 40, a to the minus 1. Okay. Okay, so listen, we're not done with this yet. This is going to be 6a plus 22 minus 40 over a. That's when it's completely simplified. Now, if you can go from the first step here again in one step, perfect. Okay? This will be on the non-calculator sections, of course. All right, product. We know how to do this. So I know that we have the term FOIL, which is one of my least favorite words. Well, I don't like using it because it's fine if you have, you know, 2 terms and 2 terms, but then if you have more than 1 term, then it doesn't really work as well. Anyhow, okay, so let's do this one. I like using the word distribute. I'm going to distribute the 3x to everybody. So 6x squared plus 15x minus 8x minus 20. So that's 6x squared plus 7x minus 20. Okay. All right, here, what we're going to do is, first we're going to do the 2 parentheses, and then we're going to multiply this one. So I'm going to leave x minus 2 as is, and then multiply the x minus 4 and the x plus 3. It doesn't matter which 2. So first I'm going to do these. That'll be x squared plus 3x minus 4x minus 12. So x minus 2 x squared minus x minus 12. Okay, distribute. Okay, now this is why I don't like FOIL, because now if you have 3 terms and 2 terms, there is no first iterator last. But we can distribute the x to everybody, and I get x cubed minus x squared minus 12x. And the negative 2 to everybody. Okay. And now I do my like terms. X cubed minus 3x squared minus 10x plus 24. Okay? All right. Okay, so let's do this one. I'm going to distribute this to each term here. So let's first do this. Okay, a to the negative 2 times a is a to the what? A to the negative 1, b to the 3. Well, you have to multiply the a to the negative 2 times a to the 1. You add the exponent. Right. Right.
Oh.
Yeah, the order doesn't matter. Minus 2a to the minus 2 times b plus 3 to the negative 2, a to the negative 2, b to the negative 1. Too many negative exponents. So here I have b cubed over a minus 2b over a squared plus 1 over 3a squared b. Right? So in each term, whatever has a negative exponent will move down. Okay? Okay, what about this one? I have G's and H's everywhere. You can either do the whole thing at once or do the top first and then combine with the bottom. Yeah. Here, this is a 9. Okay? All right, so let's do this. Let's just do the numerator first. You have negative 10. G to the 6, G to the 2 is how much? G to the 8, H to the 12, over 30 G cubed H cubed. Correct. So I do the coefficients first. So negative 10 over 30 is going to be what? Negative 1 over 3. Okay. And then G's, right? How many G's will remain? 5, top or bottom? Top. How many H's will remain? 9 on the top. So that means, you don't have to write the 1, right? So that's just negative G to the 5, H to the 9, all over 3. Okay. All right, go ahead and do E, please. Who has an answer? Yeah.
5 times 5x, 5 parentheses.
So you don't have to fact. Did you plug it all in? Anybody distribute everything? Yeah, Ariella? Uh-huh. 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 12 or 36? 36 y squared, right? Yeah, very cool. That's it. So now the next step, right, no, the next step would be, that's it. No, because then you'll just get back, you don't do anything. The next step would have been go and see if there are any like terms. So for example, you might end up with, you know, 2 terms with an x squared y. Then you have to add the coefficients and so on. All right? So if there are none, then you don't do anything. So now, this homework will be due on Monday.